Now this is just a simple digital design. We're gonna construct it using the 74163 and digital STIM1. The $D underscore H1 and L0 is the input and output, highs and low. They are just on the data ports. Make a figure as shown in the schematic. Run the simulation. In the simulation, change the setting like gate level, category, make it 0, and FP and the IOs and AD interference as 1. Apply these changes. We need to define the property of DSTIM. The DSTIM is the input to the counters. Run the simulations. You will find that it will run for the 5 seconds as we have in the setting. Added the stimulus parameter. It is just go in the digital portion, no analog. Just click on digital clock, and this is just a pulse of 100 Hertz for 50% on, 50% off. So this is the clock which we're gonna give to the both of the counters. Now take care of this thing important. We should connect the .stl file with our main profile. So go on the simulation profile, configuration of the files. The .stl file has to be selected and it has to be added to the profile. .stl only should be added to profile. Click OK. This means that this file is attached the signal which gonna go for the input. Now see the schematic. This will run from 0 to 5 seconds. Add the QA, QB and QC. The QA, QB, QC and QD are the output from particular Q1s and Q2. So directly click on digital. So these are the output. The counter reaches the 255. It begins at 0. So it reset it after 255. Now DSTIM output is the output 100 Hz on off cycle. This is all the Q1s and Q2s output, QA, QB, QC, QD. Now if we select all of this and make an expression, so this will lead to formation of a bus. So if we select all of these in the trace expression and end them with a column, then it will lead to formation of Q bus. Q bus is the bus consisting of all the outputs. So this is the Q bus, the another one trace on your simulation. Click plus, so you will come to see Q bus. Take the simulation to 0, so you say 0, 1, 2, 3, 4, 5, 6, 7. So after the 7th and 8th pulse, 8 pulses are there. more simulation. If you go, you find it. Now we're gonna make a select the bus in our main layout and connect all the QA, QB, QC in order to find that what we have done is correct. In order to get the proper bus, we have to do it this way. Now label that the Q output 720. That means the 0 to 7, like 8 connectors are there. Connect all the pins like 14, 13, 20, 12, 11, 15, the QA, QB, QC, QA, QB, QC, QD of U1 and U2. So this will be all the connectors coming from the bus. If we as we have done the zoom in the sim, we see that we can see the hex value. The hex value is this default in the simulation. Connect all those things. Make a net alias with the name of label the wire Q output 0, Q output 2. So these are the output from the Qs, like 0 to 7, 8, 4 of U1 and 4 of U2. These are all the default hex values. Now in the expression add the cube out 7. These are all the hex value. The tracks expression will be, the bus values are now displayed in the decimal values.